All right, Math 9, I am in the midst of marking the test that you wrote today. Yes, today, because I'm recording this at about 5 o'clock. So I got partway through them. You'll know because you got your mark back or you didn't. And I will hopefully finish those off tomorrow. Right now, I want to talk a little bit, just very quickly, about where we're headed over the next few weeks. And then I want to do today's lesson, not a hard lesson, all right? So we are headed into chapter 9, which is actually the last chapter of the text. It won't take us long. It will take us the rest of this week and next week, and then partway through the week after that will be a test, and we will be done all the new information. So what are we going to do with the time that's left? Here's what we're going to do. I'm going to have an assignment that's going to cover everything from your last exam till now. That is chapter 5 through chapter 9. I will make a few videos reviewing chapter 5, chapter 6, chapter 7, chapter 8, and chapter 9. I will do at least one video per chapter. For chapter 5, maybe a couple, because chapter 5 was kind of long. And there won't be any homework per se with that. It will just be review videos for you to use as reference of, I forget how to do that, and you can pull up that video and look at it. But really what you'll have is the rest of the time to work on the assignment that I give. It might be about 3 weeks that you have to do it. It will be due June 5th, which is the last day of school. So obviously it can't be late. Hear me when I say that. It can't be late, okay? It just can't, because school ends, which means you're done. So June 5th is when you'll have to hand it in. If I give it to you and you want to hand it in the first week and be done, I'm okay with that, all right? But if you want to take your time with it, it's going to be worth a significant amount of your mark for this quarter. So you want to do well on it. Don't just blow it off and go, it's good enough. Take your time with it. Go over it. If you're stuck on something, ask me questions. Ask your classmates questions. Look up my videos. Look up somebody else's videos. I don't care, but you need to do well with it, especially if you're trying to get your mark higher. There's 2 or 3 of you, maybe more, I don't know, but 2 or 3 that I know of who would like their mark to be better. Okay, here's your chance. All right, take your time with the assignment, do it well. Okay, so that's just my little pep talk. All right, so section 9.1, chapter 9, I really feel like it's broken up into 2 parts. Part 1, we talk about graphing and scatterplots. Part 2, we talk about probability. And none of it is hard. So that's the good news. It's easy. All right, so when we talk about scatterplots, what we're talking about is a graph where there isn't necessarily a discernible pattern. The dots don't go in a straight line necessarily. There might be an overarching pattern, but there isn't just a nice, like in a linear graph, if you've got your X and your Y axis, you might have like a straight line. That's not a scatter plot. A scatter plot will have a whole bunch of different information, like all over the place, okay? Now there might be a pattern to it, like with this, even though the dots are kind of all over the place. What I would say is that as my X values increase, so do my Y values, right? Because everything's kind of going up. So there is a pattern sort of, but there really isn't a perfectly straight line of dots or anything like that. Most of the time, when you see statistics, you see graphs, right now with this whole COVID thing, You're seeing graphs on TV and on the internet all the time, kind of talking about flattening the curve and those types of things. What they've done is they've actually taken a scatter plot and taken the average, and we're going to talk about this later, and taken what's called a line of best fit and created that line, okay? And so what you're seeing is that what they're saying is that we want our line to look like this. We want the curve to flatten, and we don't want it to do this. And B, we've done a really good job at that in New Brunswick. So far, let's keep it up. So, scatter plots. Let's talk a little bit about them. In this section, you do not have to draw them, but you will be drawing them in the next few sections. So I want to talk a little bit about them as we go. This is my x-axis. This is my y-axis. That should not be news. But when we have types of data, if there is what we call an independent variable, I can't spell, hold on, I mean I can spell, but not right this second apparently. Independent okay, so there's not always, well, there's always two things we're going to compare. Sometimes there's what we call an independent variable and a dependent variable. Not all the time, but sometimes. So for instance, if I was comparing the temperature outside to how many articles of clothing someone wears, so right, the independent variable would be the temperature outside, because that's not something that I as a human, that I as the person, as I the experimenter, can control. The number of articles of clothing that you wear, you do control. It depends on what the temperature is outside, right? Because if it's minus 40, I hope you're not, well, some of you might, but I hope you're not going out in just a t-shirt and a pair of shorts and some flip-flops. I hope you're putting on pants and a t-shirt and a sweatshirt and a coat and mittens and a hat and like, see what I mean? More clothes. So I would expect that as the temperatures increase, that the number of articles of clothing I wear probably is decreasing. Hopefully it does not go down to zero though, right? But that's what I would expect the pattern to look like. So if we have an independent variable, something that the experimenter does not control, that goes here. And if you have something that depends on what this is, that goes on the y-axis. Like I said, it's not always one or the other, but just in case. Now, when you set up something like this, there may be a very wide range of numbers in your data. So for instance, if we were talking about temperatures, we might be talking from 0 degrees to 40 degrees. I don't want to, on a graph, make each square worth 1. I don't have 40 squares across my sheet of paper. So you need to pick what we call a scale. The scale needs to be reasonable. You do not want your graph to be itty bitty. If you have a full sheet of paper, your graph should not be this teeny tiny thing, and I've seen it. It should not be this teeny tiny thing. I recommend that a graph take up probably about half a sheet of graph paper. You should not be able to fit more than 2, maybe 3 at the most, graphs on one sheet of paper when you're doing scatter plots. You just shouldn't be able to do it. By the same token, you shouldn't make it so that, like I said, you shouldn't make, if your x goes from 0 to 40, you don't want to make one square worth 1. Otherwise, you're going to have to start taping sheets of graph paper together, and you don't want to have to do that either. So something reasonable might be that each square is worth 5, okay? That might be a reasonable thing. A reasonable thing would not be to make this one, to start at 0, make your first square 20, make your second square 40, and make it 2 squares wide. That's not reasonable, okay? You need it big enough that you can see the space between your dots, but you don't want it so large that it's kind of nuts, okay? So, and you can't do, every square has to be worth an equal amount. You can't go, well, the first square is 5, and then we'll make the next square 12, and then we'll make the next square 13, and then we'll make the next one 17. You can't do that, okay? You can't do that. Each square has to be worth an equal amount. You do not have to make it the same on this axis as this one. If you decided to go up by 5s on this axis, but on this one it's articles of clothing. I usually don't wear like 40 articles of clothing. It may look like it sometimes, but not usually. So that you might want to go up 1, 2, 3, 4, 5. It doesn't have to be the same for both axes, okay? Axes is actually the plural. It doesn't have to be the same for both. So there's just a few tips when you're drawing a scatter plot. Again, in this section you won't be drawing them, but we will be drawing them. So I want you to hear me saying these things a few times to get it kind of stuck in your head, okay? So we're gonna look, and if you have your textbooks open, that's actually gonna be really helpful. Normally I can do that up here on the board, but with a scatter plot it's gonna be really hard to do. So I can give an approximate, but if you're looking at your graph, it's going to be a little bit easier to follow along. So you want to follow along in your textbook on page 330 with me. And I'm looking at the activity where it has a scatter plot, and it's talking about birds. And it's talking about the length of the bird from the tip of its head, from the top of its head to the tip of its tail feathers. So it's talking about what they say the length of the bird is versus the wingspan of the bird. And what that means is the length of the wings from the tip of one to the tip of the other one. And what they want to know is there a relationship between the two? And you can see on there that they chose a scale of every square is worth 25 because 2 squares over is 50, the next 2 squares over is 100, the next 2 squares over is 150, and the next 2 squares over is 200. And you can see up the side they chose the same scale. Every 2 squares is 50, so 50, 100, and they go all the way up to 400 on this side, okay? And 50 and 100 and 150 and 200 and 250, and I'm going to run out of space, so I'm going to stop at 300, but they go all the way to 400, okay? So it says estimate the least wingspan shown. So what you're going to do is look for the dot that has the least wingspan. So you're looking for one that is as low as possible. And if I look, it looks to me like there's one right about here that is the lowest that it goes. So if I was estimating the least wingspan, well, there's a line right here, and which would be 25, and that dot looks just to be above 25. So I would guess 26. Now they said it's in centimeters, so I would guess the least wingspan, the smallest wingspan, would be 26 centimeters. Now, if you said 27, I would give that to you, okay? This is an estimate based on the graph. If you said 40, I wouldn't give that to you. That's not close, okay? It has to be a reasonable guess based off of the graph. So it says estimate the length of the bird with this wing spread. So again, if I look at that dot that I was looking at, if I look at that dot, there's also a line coming up. It looks like it's right before the 25 square. So I might guess that the wing spread is 26 centimeters, but the bird's length from its head to its tail feathers is about 24 centimeters in length, okay? Again, it's an estimate, and I will be looking to see whether or not your answer is reasonable. When you check your answer at the back of the book, if they say 10 and you said 9, that's good. If they said 10 and you said 50, that's not good, all right? It should be within 1 or 2 of the answer. Then it says estimate the length of a bird that has a wing spread close to 220 centimeters. So a wing spread close to 220 centimeters. So 220 centimeters would be about right here. There would be about 220. So I would go across until I run into a dot. And again, if I look at the graph that they give me, 220, if I go across, there is a dot that looks to me to be about right here, okay? And so if I come down, it looks like it's just before the 100. So maybe I'm gonna guess about 95 centimeters, okay? So I'm gonna guess that a bird with a wingspan of 220 centimeters is about 95 centimeters long. And again, that is based on the dots that they give me. So I hope you're seeing, I'm not going to go through all of these questions, but I hope you're kind of seeing what you do. Okay? So you're going to be looking at the dots. Now they have way more dots on their graph than I have here. I just put a couple on. All right, so let's look at the example. Well, actually, no, there is no example. That's it. So that's all I want to do. I just want to go over that, okay? I want to look, at question in the activity under the inquire. It says, describe the pattern made by the points. And there's like all these dots everywhere. There's just dots all over the place. And then they kind of start spreading out up here. But overall, the pattern looks like the longer the bird, the bigger the wing spread, because it does slowly go up, right? The general pattern of the dots, it's not a straight line, but the general pattern of the dots is that they go up. So it says describe the pattern made by the points. As the X value goes up, the Y value goes up. So describe any relationship. Then the relationship would be that the longer the length of the bird, the bigger the wingspan. And that makes sense. It would look pretty funny if you had a little itty bitty hummingbird that had a 2-meter wingspan. Like that would look funny, right? It's proportional. And that's really all they want. When they say describe what's going on, literally just describe what's going on. As we move to the right, the dots go up, which means the longer the bird, the bigger the wingspan. That's all they want for an answer. Don't overcomplicate that. It's not supposed to be hard. All right, I'm going to give you a few to try, and that will be it for today. Again, we probably have a week and a half worth of work left. Then I will make review videos and give you an assignment to do. All right? For those of you who are online students only, I am going to give you the assignment. I'm going to make those review videos so that you can watch them. You do what you can of the assignment. What that will do is let you kind of know in relation to what we at Moncton Christian Academy have learned. What parts of it do you know and what parts of it do you not know? And hey, maybe you'll pick up some things along the way. Who knows? Um, so we will, that's where we're headed over the next few weeks to the end of this year. All right, so we'll talk to you soon.